In this video, I want to discuss inflection points. An inflection point is a point where concavity changes. So you might have a graph that looks like this, so it's concave up, and then it starts turning down, concave down. So this is concave up. On the right-hand side, the graph is concave down, and somewhere in between we change concavity. The concavity changes from up to down about right here. So this is the inflection point. Or it might have a situation like this. We start off concave down, so we're turning downwards, but then we start picking up. We start going concave up. So here is the inflection point. It's the place where we go from turning down to starting to turn up. Okay, let's look at a more global example. Here's a graph of a function f, and we want to find the inflection points. So we look at the graph going from left to right. Here we're turning down. And we keep turning down until about right here, where we start turning up. So here I'm turning up, and then somewhere around here, I start turning down. And somewhere around here, I start turning up again. Okay, it's pretty imprecise, but you get the idea. So here's a place where I change from concave down to concave up, concave down to concave up. So there are 3 points of inflection. Here, here, and here. Those are my inflection points. So where I change from concave up to concave down, or vice versa. Okay, how do we understand concavity in terms of derivatives? Well, here's the things we have seen before. Concave up corresponds to the derivative increasing, or the second derivative being non-negative, either positive or 0. Concave down corresponds to f prime of x being decreasing function, and f double prime of x being either negative or 0. So that means that if I want to understand the change from concave up to concave down, or concave down to concave up, I just need to look at a change in the direction of the derivative, either from increasing to decreasing, or decreasing to increasing, or I can look at a change in the sign of the second derivative. So I can do either one of these to check the change in concavity. So for example, if I see that the sign of the second derivative is changing at a particular point, that point must be an inflection point. So these are 3 different tests for finding inflection points.